Hi, Mrs. Ramirez here. We're working today Module 1 and Lesson 28, Solving Percent Problems. As we have done every time we work on percents, we remember percentage means out of 100. Our chant, it is a part to whole ratio. We need to remember that because, especially for today, it's going to be important. So, our part to whole ratio, for example, if I do 72 to 100, percentage is out of 100, that's why I chose 100. We could write it as a fraction. 72 is my part, whole is 100, and that equals 72%. It also equals 72 hundredths using the decimal. Today we're going to work very specifically looking like a fraction because it can show very well the part versus the whole section. So today's example, if an item is discounted, that is the part off, that's what you save. Then what is the percent of the original price? Okay, interesting. Remember, percent is out of 100, so the original price is going to be, as a percent, 100%. That is the whole. And here we've got our percent. It is the part. We've been talking very much about the part versus the whole ratio. Today we're going to distinguish between the two different parts. And so that's the main part of main gist of what we're doing today. So if we have 100% and that is our whole, that is our original price, I have to take away 20%. That is our amount of discount. Guys, these labels right here are really important, so I really want you to write these labels down. It's going to help you when you get to the exercises. Amount of discount, that is the sale. That is what you pay. I have to pay that amount. 20% is, no, sorry, the amount of discount, it is what you save, not pay, sorry, save. And when I take 100 minus 20%, I have 80%. This is the sale price. It is what you pay. Okay, so the amount of discount, what I take out, and what I pay for. Now we've been talking part to whole. This is our whole, and the whole is very much the original. However, we now are distinguishing between two parts. This is a part, the amount of what you save, the discount, but there's also a part of what you pay, the 80%. And it depends on how we make our ratios. So I wanted to be very specific with this because it's going to help with the backside as well. So if the original price is 400, this is our whole. What's the dollar amount of the discount? Okay, so what I need to do is find the part to whole, the dollar amount of the discount. Well, the discount is 20%. That is what you save. So I'm going to add an extra label here, but these are going to be really, really important. I save 20%, 20 out of 100. And the original whole is going to be 400. The wholes don't change. Percentage is always out of 100, and the whole will always be in the denominator as well. But it's these parts. that are going to change. So I need to use and also label very specifically save. This part is what's going to be what I save. So now I can use my giant 100 times 4 to get 400. 20 times 4, it will give me 80, sorry. So 80 is my discount. So 20% discount. And that is what I save very specifically. It is $80 saved. So I have saved $80. The amount of the original price is $400. So now what I need to do is take $400. So how much is the sale price is what they're asking right here. Move it up. Sorry for the noise. 400 minus what I saved, 80. This is my original. Again, this is my whole. This is $80 off. This is the sale price. This is what you saved, the discount. And I'm being very particular about these labels. This is what you save because we are very much using them. 400 minus $80 to save gives me 0, borrow, 10 minus 8 is 2, 380. This is what you pay. Okay, so this is the sale price. I'm going to give you a second to write down, make sure you've got all those labels. They're going to be really, really important. So the sale price is $320. Okay, now we've got that, and I'm going to continue working, and it's way back at the bottom. The noise is going to make a noise. Hold on, sorry. Let's make a table because it's going to be just like the exercise. So, and I'm modeling it very specifically off the table. Here's the original. We're going to have a sale price. This is what you pay. Then there's the amount of discount. This is the sale. This is also what you save. Okay, now I'm going to make this actually kind of large because it's different. This is going to show me the percent saved, which is what they started with in this problem, and the percent paid. This is the sale price. Okay, so what they gave us, and I'm not going to move the paper because it'll make lots of noise, but what they gave us, the $400 is the original. That's my whole. Whole, always, always. There's two different parts. That's why we're being very specific. So 400, the percent is the sale price off is what you saved, 20%. Now, percentage always equals 100. So when I add the saved price plus the price paid, it's always, always, always going to equal 100% because 100 or percentage always means 100. So, and we figured out here that the 80% was the sale price at the very top. So we're going to, when we flip over, add this specifically starting. Okay, now what we figured out is the amount of discount, the sale. This is what you saved price. This is our $80. And the sale price, what you end up paying, which we had was $320. Now, in order to get this part of the table to work, I can see that it's 400 minus the 320 to equal $80. That is what you save. Okay, now make sure you write that down because it's going to help in the next video, which is going to be the example. Nope, sorry, this is the example, the exercise. Happy learning. See you in a second.